All right. Like I promised you, this is the last video. Technically, if you done the first part, which it was ball driver, then having the second part, which is colliding balls, it should be very easy. I eliminated the color changing because um, it was difficult to show you how they actually interact with each other. So if I look at the colliding balls um, program, the class, you'll see that it's still very short, very small, and that's because of all the work that you already did with the first part. So you should be able to see what we already had in the original program, right? All of this was there. Mm, Here's the new stuff right here. We have two nested for loops. We have I and j, and for as long as I and j are not same, they're equal to each other, then all I have to do is call the move method. But this move method is a little bit different. Just like the constructor, take a look at the constructor when we created in the ball driver. The constructor could take one argument, like v1 over here, or no argument. And remember, we call that overloading. Well, we can do the same thing for a method. In this case, the move method. So the move method over here, in this case, is taking an argument, which is actually another ball, an object of another ball. So all I have to do then is overload the move method. Those two got, the two of them got stuck. Maybe one of them would bounce into it and push it off. That has something to do with nothing. Come on, somebody bounce it. Yes. No? Oh, it's not pushing them out of the way. Anyways. Oh, no, still together. They're stuck in that distance that we set up to be. Let me restart it. Oh, no, they're not going to move from each other. It's been running for a while. This is just happened now. All right, let's run it again. I guess there is always a probability of that happening because we have a random. We're using random for velocities and for locations, for just about everything, which makes it interesting. But let's take a look at the overloaded move method. So this is the original. We already talked about this one in one of the last videos. Nothing different. So let's take a look at the one that takes an argument, like ball, another ball. This is the one that is being called in the actual driver over here. This move over here refers to this one, the one that you overloaded from the original. This is the original. So I'm going to overload this one with a different argument. For as long as I have different arguments, then I know that the compiler is not going to complain and they're going to be fine. So what's the difference between this one and the other one? Let's see if I can put them together. Let's take a look. Right. And this one, as you can see, we're looking at something that we already had in the constructor. And that's what we use B, because in the constructor, we had decided to put the extra ball in there. Well, in here, we're going to have to do it differently. All the balls are created pretty much as one. Is it the one the colliding? Yes. If you look over here, none of the balls that you create in this array of balls has an argument over here. So it's going to be using the original constructor. So how do we pass the balls that it's bouncing with? Well, in the move method, and that's exactly what I'm doing. So I'm technically not doing much of it different. I don't think there's any different over here. Take a look. This is the original, using B because B is coming from the actual constructor. Let's go all the way to the top of the constructor. And here it is. The constructor defines B as the argument that we take. And so all I did in the move method, I copy and pasted it, and I gave it an argument. What? Well, an object of ball. And I called it B, so I don't have to change any of the code. Let's go to the detected method. What is that called? Collision detected. The collision detected now, I had to handle two scenarios, right? One in which it's lonely by itself, and the other one in which it's not. That's because, I mean, do I really need this one? I don't think we need this one. I didn't test that. But in the one that it says that it's not lonely, meaning it's bouncing against another ball, then I am going to just do this, which is all I ask you to do erratic movements, right? As opposed to in against the wall, it's just changing the direction. So in collision between two balls, I just wanted to behave weird, that's all. And that's why I'm using the random feature to set the Vx and the Vy for the acting ball, and the one that is actually as part of the argument of the move method. And I need to use the set methods. This is all about two important things. Number one, encapsulation, and we already agreed that all the instance fields are private. And that means that will force us to use getter and setter methods. And the last part, or the next subject that we talk about, that we emphasize, is overloading. So here's my move without an argument, and here's my move with an argument. Do they make any difference in the code and implementation? Not really. What makes a difference is in the collision detection or collision detected, which I'm questioning that too. Anyways, because collision only happens when there are more than one ball, so it will always be not lonely. Let's test that. So let me close this. We already determined that there is in fact a good algorithm showing that they do bounce, and once in a very rare you'll get stuck, and again it's because of that randomness in there. If you get a number very small, then they get trapped in the range of collision. Where do I have that collision? Right here. So if the number are very tiny of the velocity, and then it's going to be the number is going to be, when it bounces, you're still going to get a distance that is smaller than this, and it will have collision, and it will not. There we go. There it is. Right now they're trapped, those two, because the numbers are very small. Take a look over here, these numbers, and that's the randomness, which is